Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Muhammad Zulkifli. My student ID number 05150400109. At this time, I will explain about my final project entitled Hazard Identification in CNG Station Installation using Hazard Operability and Cost Consequence Analysis Method. The background of this final project is an accident that occurred in March 2019 in Karachi, Pakistan, a cylinder explosion at CNG filling station, and at January 2020 in Peshawar, Iran, a car explosion during CNG filling process at the station. To overcome the occurrence of this hazard identification is carried out so that in this study, the problem statement is how to identify hazard in CNG station using hazard operability and cost consequence analysis method for the high risk, and how recommendation give to CNG station to reduce the risk. From the formulation of the problem, it's known that the purpose of this research is identifying hazard in CNG station using hazard operability and cost consequence analysis method for the high risk, and provides recommendation to CNG station to reduce the risk. As for the scope of this research was conducted at the Krungkut CNG station. The method used are HAZOP and CCA. Cost calculation is not discussed in this study. The following is an illustration from CNG station. From the gas flow from the PGN is flowed to the compressor. From the compressor, then distribute to the storage tank MP storage. From the storage tank MP storage is flowed to the dispenser. Then from the dispenser is flowed to the consumer storage tank. As for the steps taken in this study are: first, determine the formulation of the problem. Second, conduct studies, both field studies or literature studies. After conducting the study, the third step is collecting data. The primary data is interview and observation. The secondary data is piping and instrument diagram CNG station and CNG station component and function. After the data is collected, the fourth step is processing the data. Number 1 is hazard identification using hazard operability method. Number 2 is risk assessment. Number 3 is hazard identification using cost consequence analysis method. The data that has been processed is then analyzed, where after being analyzed, the appropriate recommendations are determined. The final step is to take conclusion and suggestion in this study. The following is the piping and instrument diagram CNG station. From the piping and instrument diagram, obtain 9 study nodes. From 9 study nodes, there are 2 high risk categories. One of the high risk category is found in study node 3. The following is the study node hazard operability table 3. From the table, it's known that the high risk is the high temperature on the compressor with a red risk category. The consequence of that risk is the compressor explode. The next high risk category is in study node 9. From the following table, it's known that the high risk is other flow in dual gas dispenser. The consequence is gas flowing into the environment so that it can trigger a fire. The 2 high risk category become initiating event in the consequence method. Cost consequence work process that is started by doing event tree analysis. The event tree analysis high temperature on the compressor has a pivotal event, such as a high exchanger, temperature switch gas, and manual shutdown. If the heat exchanger success, then the temperature is normal. If the heat exchanger fail, then the temperature switch gas is success. The compressor is shut down. If the heat exchanger fail and the temperature switch gas fail, but the manual shutdown is success, the compressor is shut down. If the heat exchanger fail, the temperature switch gas fail, and the manual shutdown fail, there is exploit of compressor. The infantry analysis other flow on the dual gas dispenser has pivotal event, including closed nozzle, emergency stop button, manual shutdown. If the nozzle closes successfully, then the flow is controlled and the process runs normally. If the nozzle close fail and the emergency stop button is success, the gas dispenser is shut down. If the nozzle is not closed, fail close, and then emergency stop button is fail, but manual shutdown is success, the dispenser is shut down. If the nozzle not closed and the emergency stop button is fail and manual shutdown is fail, there is trigger a fire. After conducting the event tree analysis, the next cost consequence analysis process is making a fault tree analysis. Known fault tree analysis at high temperature on the compressor has 6 basic causes. As for the 6 basic causes, namely component not calibrate, lack of maintenance, block pipe, corrosion, design error, cooling fan doesn't turn on. While the faulty analysis in the other flow in the dual gas dispenser has 6 basic causes. As for the 5 basic causes, namely careless worker, lack of maintenance, car driver does don't obey the rule, worker late to close the nozzle, and power failure. The last process in the cost consequence analysis work, namely making cost consequence diagram. Here is the cost consequence diagram of the high temperature on the compressor. This is and this and this here is the cost consequence diagram of the other flow in the dual gas dispenser. From the from this analysis, the result obtained, there are 9 study notes in the hazard operability method in this study with 22 low category, 13 medium risk category, 6 high risk category, and 2 very high risk category. The other result is, it is known that the incident sequence minimizes the cut set of the consequence analysis method with the type of event in the form of maintenance, environment, design, and active equipment failure for the high temperature of the compressor. Whereas the other flow in the dual gas dispenser has the type of event in the form of maintenance, environment, human error, and active equipment failure. From the analysis, as for the recommendation given by this research is, number 1, perform routine maintenance and component replacement if it experiences damage to the temperature switch guards, heat exchanger, pressure switch guards, relief valve, cooling fan nozzle, emergency stop button, and electrical system. Number 2, ensure that every safeguard is properly calibrated. Number 3, the use of relief valve pipe according to design. Number 4, conduct safety induction, emergency response training, and emphasize discipline in employees. Number 5, install safety sign around the risk area. Number 6, act firmly on consumer who are ignorant of the risk of harm. Okay, as so many presentation for me, if there are mistake, please forgive me. Wassalamualaikum warahmatullahi wabarakatuh.